Hi everyone, my name is Brian. I'm a pre-sales engineer, and what I'd like to do is offer a very simple presentation of SDN, Software Defined Networking. This presentation is intended for all audiences in the information technology field. It can help those who have a vague understanding of SDN. It can also be used by current IT professionals who need a refresher. It's also intended to introduce how SDN is applied in modern enterprises today. Creating a network is very expensive, especially when it comes to major enterprises. A lot of these big businesses tend to buy specific hardware to run their network. Things like load balancers, firewalls, routers, mass storage devices. These type of devices could cost a lot of money. We're talking about thousands and thousands of dollars. That does not also consider the licenses that are required to run certain hardware. This also does not consider things like the cables and circuitry that is required to connect these devices. Again, this can all get very expensive. Software-defined networking allows so that these type of devices can be virtualized. So instead of spending great deals of money on things like a load balancer, a firewall, a router, etc. and so forth, all of these expensive dedicated hardware are just replaced by this one box. Instead of having this big rack that has all these different devices, you have a smaller rack that has the ability to virtualize the functions of those devices. This is what we call network function virtualization. SDN is a vendor agnostic solution. What this means is that box dedicated for the network has the ability to virtualize different hardware from different manufacturers. SDN eliminates the problem of having to use only one vendor for the specialized hardware used in network functions. How is SDN managed? SDN can be categorized as a form of network architecture. There are 3 layers. The first layer, which is at the very bottom, is the infrastructure layer. This is where the network forwarding equipment is. It is the physical switches with the network. In other words, it is the physical box itself, the SDN box. The second layer is called the control layer. This is what provides the configuration and forwarding instructions itself. It is called the smart controller, otherwise known as the SDN controller. The SDN controller resides on a server and manages the policies and the flow of traffic throughout the network. The third and final layer is called the application layer. This contains the typical network applications and/or functions an organization would use. In other words, this is the software which is used to control the virtualized hardware. The primary function of this software is to separate data into 2 different planes, the control plane and the data plane. The control plane contains all the rules and policies used to manage the data plane. The data plane is the flow of data itself. It cannot forward itself without the commands of the control plane. The data plane could be that of database traffic and VoIP traffic, just for example. There is also a logical plane called the management plane, which commands the control plane. Drawbacks of SDN. Because all network functions are located within the one box, if this box crashes, then the network itself is also down. Another potential risk comes from misconfiguration of the devices. It's very easy to misconfigure the architecture. This could cause a serious security problem. We've covered all the basics of SDN. Now let's look at how it's integrated into today's business use. Software-defined wide area network, SD-WAN for short. SD-WAN applies SDN network connections to a very large geographical location. It's used to aggregate multiple types of network connections, including MPLS, broadband, and wireless connections. Think of SD-WAN as an intelligent way of rerouting traffic. For example, if your MPLS path is congested, SDN policies can be implemented to reroute the traffic through its alternate broadband or wireless paths. Imagine how beneficial this would be for an enterprise that has several different branch offices which may need network prioritization. SD-WAN offers network prioritization thanks to the control plane and the data plane scheme. And lastly, SD-WAN provides end-to-end encryption across the network, offering security. For clarification, the alternate traffic points in SD-WAN are not the same as having a failover in VPNs. A VPN requires two ending tunnels, one as primary and the other as a backup. This will require manual configuration of physical routers. Where to buy SD-WAN? Initially, OpenFlow was the original platform which offered SDN as a network solution. Today, there are several SDN providers. Bear in mind that SDN does not have an industry-level definition. Each provider has its own approach to troubleshooting its product. Because of this, support is limited to the vendor of that specific SDN box. This concludes my presentation. Thank you for having watched this video.